All right, lesson 5.3. So we are using graphs of the first derivative to make justifications for what's happening in the original function. All right, and there's a couple of things I want to highlight. I'm not going to read through this word for word, but this is a really common type of free response question on the test. Is it gives you a graph like the one below of a derivative, and it wants you to use that graph to tell them what is happening on the original graph, and then you have to use the graph to justify it. Okay, couple of things stand out here that I want to emphasize maybe more than the others. First of all, justifications need to be short. If you are writing more than one sentence, you're probably going too far. Explain what you need to explain and be done. What happens a lot of the times is you get wordy and you feel like you need to add more and more information. You don't. Keep the answer simple. A lot of times people, they get that second or third sentence written down and they make one little mistake because they're trying so hard to show their thinking. And that, even though everything else is true, that one mistake makes the entire answer incorrect. All right, so we're going to try to keep this to one sentence justifications at all times. If it helps you to draw like the number lines, like the sign charts where we do, like if this is f prime, what's happening? Here's my zeros at -2 and 2. That's not this problem. I'm just using it as an example. You can use the f double prime number line to help you figure out and see what's happening in the problem. But these are not justifications. You have to write a sentence justifying why your answer is what it is. They just help you maybe sometimes justify it. On top of that, you have to use this information to justify. All right, if you're justifying something about the f function, you need to talk about the information they gave you and use it as the justification. Okay, so let's do some examples here. The graph below is a graph of f prime, the derivative of f. This graph of f prime has horizontal tangents at x equals plus and minus 2. So it's telling you right here at -2 and +2, the slope is 0. And it has a domain of -infinity to infinity, which is important information. So it says, on what open intervals is f increasing? So looking at this function, this is the derivative. Remember, this is f prime of x. Where is my original function increasing? And there's a lot of different ways to think about this problem. I start with, what does it mean if f is increasing? If my function is going up, it's increasing, which means it has a slope that is positive. All right? Well, what does that look like in this graph? Okay, it doesn't give me my function, it gives me the derivative. And where on this graph does it represent a positive slope of my original graph? And that's not too hard to see. It's everywhere that my y values are above 0. In between these values here, my derivative is above 0, which means that my function had a slope above 0. Remember, these y values, sometimes if you write that the y value is the slopes of f, that might help you as well. So what I would say is from -4 up until 0, and from 4 to infinity, because it tells me my function goes all the way to infinity, f is increasing because, now my because has to be based on the graph it gave me. So I'm going to say because f prime of x is, I could say it's greater than 0, but I'm going to say f prime of x is positive. All right, so in that interval, f prime of x is positive, so that means my function's increasing. On what intervals is f decreasing? Well, f is decreasing when it's going down, which means it has a negative slope. And since this function is giving me the values of my slope, all these negative values, all these negative y's, is where my function is decreasing. So for example, at 2, right here, my function is decreasing at a rate of, it doesn't really tell me what that value is, but that looks like it might be -2. So my original function at x equals 2 has a slope of -2. Remember, that's what those y value means. So I would say that on the interval, if I want to get a little bit more professional in my writing, on the interval 0 to 4, and if these are brackets, no big deal. It's going to give it to you whether they're brackets or parentheses. On the interval 0 to 4, f is decreasing because f prime of x is less than 0, or because f prime of x is negative. And you're done. Don't start adding more information because that's where you're going to start getting into trouble. Okay. All right. At what x value does f have a relative maximum? So again, I think a lot of times the picture helps me answer this question. If f has a relative maximum, that means my function's going up and then coming down, which means that I have positive slopes right here and then negative slopes on this side. So I'm looking for, where does my x value change from a positive slope to a negative slope? And when I look at f prime up here, these are my slope values. So all through here, I have positive values of the slope. And then right here at 0, it changes to negative slopes, which means my function is now going down. So at what x value, I would say when x equals 0, f has a relative maximum because f prime of x changes from positive to negative. And that is more than enough. That is why I have a maximum. When do you have a local minimum? All right, so to visualize that, my function is going down and then it's going up, which means I have a negative slope over here, and then it changes to a positive slope. So I'm looking for the x value where my slope changes from negative to positive, and here's all my slopes. They're negative slopes, negative slopes, negative slopes until this value 4. Then it changes to positive slopes, right? So when x equals 4, f has a relative minimum because f prime of x changes from negative to positive. And you stop talking right there. That's all the explanation you need, okay? Number 5, on what interval is f concave down? All right, so again, I want to try to visualize what's happening in my function, my original function to be concave down, right? So if my function is concave down, it looks something like this, right? And we know a little bit about concavity when we're dealing with f double prime. If f double prime is negative, then my original function says it's concave down. But I don't have f double prime. I have f prime. Now, and here's where you need to be careful. I can't use f double prime to answer this question. I have to use f prime. So if f double prime is negative, if my next derivative is a negative number, then that means that f prime had a negative slope. That's why f double prime is a negative number. So that means f prime is decreasing. So let's look at our f prime up here. When is f prime decreasing? Well, I'm going up all the way until I get to this point, -2, and then I'm going down. I'm decreasing all the way until I get to +2, and then I'm going back up again. All right, so f prime is decreasing from -2 to 2. So I would say on the interval -2 to +2, f is concave down because f prime is decreasing. I can't say because f double prime is negative because it's not giving me the graph of f double prime. I have to use f prime to make that justification, all right? This is another one where you could have used our little number line sign chart thing. Sorry for the interruption. This is what happens when you record a video during school. F double prime sign chart. Remember, you want to know when would f double prime be 0 when you're making this chart. So you're looking for the slope of f prime to be 0. Well, it's 0 right here at -2, and it's 0 right here at +2. So if I look at what's happening in between those values and before and after those values, well, before -2, my f prime is increasing, which means I'm going to have a positive f double prime, which means I'm concave up. At 0, f prime is decreasing, which means I'm going to have a negative slope, which means I'm concave down. And at 4, f prime is increasing, right? Over here, f prime's going up. So that's positive slopes, which means positive values for f double prime, which means concave up, which might be the next question. At what x value? No, it's not. It just wanted to know concave down, okay? On what x values does f have a point of inflection? All right, so we need to think about what's happening at a point of inflection. So points of inflection, I know that they happen or could happen when f double prime equals 0. But I'm not dealing with f double prime. I'm dealing with f prime. And not only does f double prime have to equal 0, but remember that it has to change signs at that point. So if my function is changing concavity, then my slope is increasing right there. And what makes the change of concavity is now my slope is decreasing. So I'm interested in when is my slope increasing and when is my slope decreasing? Because if it changes from increasing to decreasing or the other way around, then that means I have a point of inflection because my concavity is changing. So let's look at our function here. When do I change? I increase. F prime is increasing until I get to 2. And then f prime changes to decreasing until I get to, to -2. And then f prime is decreasing until I get to +2. And then f prime starts increasing again. Okay, so I change concavity here at -2 because my f prime function changes from increasing to decreasing. So I change concavity. Well, let's rewrite. It wants us to use the word point of inflection. I have a point of inflection at x equals 2, or -2, because f prime of x changes from increasing to decreasing. I just don't want you to have to sit through me writing, so sorry for the shorthand. And then if I look again, my function is decreasing, and then it changes to increasing at positive 2. So, and at x equals 2, because f prime of x changes from decreasing to increasing. All right, number 7, on what intervals is f decreasing and concave up? Justify my answer. All right, so it wants to know, when is f decreasing and when is it concave up? Well, if f is decreasing, I know that that happens when I have a negative slope. So that means f prime is going to be negative. And if f is concave up, then I know that f double prime is positive, which means that f prime has a positive slope or is increasing. Might be a better way to word that one. So I'm looking for, when is f prime negative but increasing? All right, so f prime is negative right here, and it's increasing, it's going up. So I would say that's going to be from negative infinity to 4, and let's see if it's happening somewhere else. Now f prime is positive, 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 positive. Now it's back to decreasing, or negative values, but I'm decreasing until I get to 2. And then at 2, I'm increasing and I'm negative until I get to the value 4. So from 2 to 4, f prime is negative, but it's increasing. So let's add that. From 2 to 4, because f prime is negative, f prime of x maybe is better, and f prime of x is increasing. Done. All right? Homework problems. Give them a try.